Welcome everyone, and it is a pleasure to be with you. And it is again the Ask Me Anything session, the monthly update of Hill Helicopters. We are so anxious to hear more of this update that we've been hearing every single month, and it's great to have people connecting from all over the world. All the continents are here represented usually, and this is going to be again what's going to happen today. And we have been doing these sessions now for a little bit over 2 years. And more of 20 of the Ask Me Anything sessions have happened. And we update the status of the build of the aircraft. Misha, what do you gather what's going to happen today?
Today's going to be an amazing day. We have some pretty exciting things in store for you guys. I think you're going to be really, really excited about this one. Jason's going to present for about 45 minutes, maybe a little bit longer. There's lots of things to show that it just keeps evolving. More and more things are going to be able to be shown now at these AMAs. So that's going to be a really exciting time. And then, as we always do, we're going to switch over to the AMA session. So AMA stands for Ask Me Anything. And Jason's open to any questions that you guys might have. We've got the chat there for you guys to be able to be posting that questions. We encourage you during the session to be posting all those questions. We're going to be taking note of those. And then at the end, we're going to be posing those questions to Jason, and he's going to be able to answer all of those for you guys. So without further ado, we want to pass the time over to Dr. Jason Hill, the founder of Hill Helicopters. Go ahead, Jason.
Thank you, Misha. Thank you, Ruben. And welcome, ladies and gentlemen, back to DC1. We've got a fantastic presentation for you this evening. We're going to focus primarily on composites this evening because we've had an amazing run with our composite development over the last couple of months or so. So that's the primary focus. I'll give you a bit of an update on the engine and drivetrain. We'll talk briefly about the digital cockpit, and then there's some more exciting news about the evolution of our production facility. So, cost-effective composite technology is at the heart of the performance, the safety, and the game-changing price point of HX50. And for that reason, tonight we're going to be talking predominantly about our composite development process. So it's only been around 18 months since we took the bold decision to make the main structure of HX50 in a single piece, a monolithic carbon fiber crash cell, beautifully styled, aerodynamically sculpted to give us the balance of performance, strength, and importantly, cost effectiveness that we need to bring this game-changing helicopter to market. In addition to that, we also laid out how we intended to make this thing with a very clever arrangement of external tooling. Since then, we've pulled together a range of technologies from lots of different industries involved in composite production to bring the price point of composite manufacture down to something that we needed. Now, in order to do that, we've had to reject the aerospace norms. We've had to vertically integrate not just the carbon fiber manufacturing, but the pattern making, the mold making, and then the part manufacture itself. And with that has come end-to-end control of the quality, the schedule, and the cost. Not just the cost of making the finished airframe, but also the cost of developing a viable airframe. Because if a set of patterns and tools cost you huge amounts of money, you're not going to be inclined to want to iterate the design. And of course, building stuff and iterating the design is by far the fastest way to refine and converge to the solution that we know that we need. And so that's what that's been our approach all the way along, and that's what tonight's session is really all about. And so we've made it very clear for a while that one of the key ingredients to our composite approach is the use of infusion. And what that means is we can buy the carbon fiber in the cheapest possible form, so aerospace grade fiber, but in the lowest format, cost format that you can buy it, high quality resins, again in the lowest price point format that we can buy, and then add the maximum value ourselves. But to do this, we've had to master a wide range of techniques to allow us to hold the dry fiber, stick the dry fiber to various parts of the mold, and then manage all of the infusion process parameters to the extent that we need to create aerospace grade structures. And that's precisely what we've done. Now, once we've done that, we then had to produce a bunch of material specimens and validate that this combination of processes, this combination of materials, this workflow enables us to produce composite material that has the required mechanical properties to be viable for an aircraft structure. You need that high carbon content, you need it to be profoundly defect-free, and you need it to be repeatable and controllable. And so we produced a bunch of test specimens, they went off and got tested, and by the time we'd got all of those elements together, we believed that we could produce a one-piece carbon fiber fuselage. Now, to bring all of those parts together, we elected to make a third scale model. And that was really just to prove the point, and to prove the point quickly before we had to invest in vast amounts of infrastructure, vast amounts of additional people and expertise to build a full-scale airframe. And so that's precisely what we did. A little under a year ago, I think it was 10 and a half months ago, we set about producing a third scale version of the HX50 fuselage in order to bring together the tooling technologies, the molding approach, the infusion strategies, the dry fiber handling techniques that we needed to use, and then to deal with the feature definition, the fit and the finish of all of the ingredients that we needed to make a one-piece carbon fiber fuselage at a price point that could bring general aviation back to life. And that's precisely what we did. And what we've got over here is the original third scale models that we showed you previously. So if we just go over here, what you can see is the third scale model that you've seen before embodies all of those things. We developed it, we developed the infusion strategies, we got all of the details right that allowed us to create sharp edges, get the lightning strike protection in there, and prove that we could make these fuselages in a single piece. We then went on to develop the processes that you need to be able to finish carbon fiber to the standard that people expect when they're buying premium products. Now, as you can see, native carbon fiber, when it comes out of the mold, doesn't give you a perfect surface finish. There's a texture to it in a lot of the cases. And so we need to minimize the amount of work that needs to be done to this when it comes out of the mold, which we have developed a bunch of techniques to do. And then we needed to demonstrate that we could produce a high quality finished article at the end of it. And indeed, we did that, and we did that quickly and cost effectively. With all of those things resolved, the very next thing to do was to invest. We had to build the capability, we had to build the business that was going to build this full-scale fuselage. And so what we did then, we had to expand the team. We were joined by some experienced composite manufacturing experts. We developed the facilities. We needed to create a pattern manufacturing facility, a large-scale CNC production facility to make patterns, to trim molds, to trim parts. And we were able to do that in just 3 months. With the team in place and the facilities in place, we then set about building patterns. Now, our whole cost base for the helicopter requires us to be able to make patterns, molds, and the finished parts at a price point that's acceptable to general aviation. And that's precisely what we've done. Down at DC2 and DC3, we can make all of the elements that go into producing an aerospace-grade composite structure in-house, ourselves, at the price point that enables what we're trying to do. And so with that done, we built the patterns, we developed all of the necessary controls and techniques that go into building patterns to the right standard, and from that we were then able to develop the molds, we were able to develop the dry laminating processes, the infusion processes, the trimming processes, and then the surface finish processes, and all of the things that you have to do to handle these huge molds to make a full-scale fuselage. So what I'll do now is I'll show you what these patterns actually look like. So what the first stage in this whole process actually is. Let's go over here and have a look. So what you can see in front of you here is the pattern for the belly of HX50. So these two big apertures here are the undercarriage doors, and then the various things that you can see around the side are evidence of the various refinements that we've taken in surface sealing, panel sort of pattern vacuum integrity, surface quality, and all the other steps that we've had to go through to get these patterns to the point where they do the job properly. And this hasn't been easy. This has been a very, very, very hard-won process. And again, to reinforce the point I made earlier, some of these things you only learn by doing. And so the techniques required to work on these patterns, the techniques required to move these patterns, some of the body side patterns are actually made in two halves. So being able to align and manipulate those patterns, handle them and store them, all of these things have been developed by us from scratch to be able to deliver this in the way that you can see it in front of us. And in terms of further refinements to this, the very next stage of this is to develop a range of heating and temperature control processes to enable us to better control the infusion as we make molds from these things. So the basic recipe, as we've shown you before, is essentially derived from boat building. So we have a low-cost polystyrene base, a fiberglass cover, and some magical sealing layers on top that give us the vacuum integrity we need to be able to create high-quality infusions. Now, once you've done this, you're then in a position to take molds. And the molds that we've made for HX50 essentially come in 5 enormous pieces. Let's go and have a look at them. Sorry, I'm forgetting myself. So the molds that we've got, sorry, I'm jumping ahead. The molds that we've got are essentially made in 5 giant pieces. So what you can see here is, and again, ignore this big thick green coat on the outside. That's one of the measures that we've taken to improve the vacuum integrity on these early molds. What you can see is the 5 pieces are joined together externally because we need to surround the fuselage to be able to remove the molds and extract the fuselage from the mold when it's finished. Each of these flanges has got complex sealing arrangements inside there so that once they're sealed, they create complete vacuum integrity. And then we bag to the inside face of the tool in order to be able to create an envelope in which to put the carbon fiber, the reinforcement material, and then infuse into. So if we go and take a look inside, I'll show you what we've done to create a tooling surface that we can work from. So inside, what you can see is we've generated a much smoother surface, and this is the surface that transfers directly onto the part. So what you can see in here is this is the environment that the guys have to work in to make the fuselage. So it's important, these apertures here need to be big enough to get the carbon fiber in, for the guys to reach in, to be able to bag, to be able to get the infusion media in, and then ultimately to draw down a vacuum and infuse the fuselage in a single piece. And this process again has been quite a demanding process to master. You know, there's a lot of elements go into being able to produce these panels that have got sufficient vacuum integrity themselves, sufficient vacuum integrity between the joints, and then all of the other things that you have to sort out to be able to get everything in and out that you need to, and finally to release the part from the mold. And we've completed that successfully, and these are the first set of molds that we produced to create the very first HX50 fuselage. Let's go and have a look at how we built that fuselage. Okay, so with a molding strategy developed and then validated at full scale, with a set of molds that can hold a successful vacuum with access in there so that we can actually get all of the materials in there, the very next stage is to make the fuselage itself. Now, in order to make an infused part of any description, you have to be able to hold a near perfect vacuum. So the way that we seal around the molds and around the finished arrangement of molds is absolutely critical, and a lot of effort has gone into developing that. In addition to that, we've then got to get the carbon fiber in there. So the first plies can be done by disassembling the arrangement of molds, kitting and laying the carbon fiber into those molds. But of course, then we have to fall back on all of those techniques we developed on the 3rd scale model to be able to stick that dry fabric to the walls, stick that dry fabric to the roof, and then to be able to attach all of the infusion media, the resin distribution media, the pipes, and everything else that you need to be able to create an infusion. Once we did that, we then had to draw a vacuum, we have to maintain a vacuum, and then we use our computer-controlled infusion machines to be able to push the resin or draw the resin through the mold to deliver a cost-effective and practical infused component. With the infusion complete, we then demold it, and then all of the excess material has to be deflashed and trimmed, and that reveals the very first HX50 fuselage. So let's go and take a look at what it looks like. So it's taken me about 25 years of my life to get to this point, where we've managed to build the very, very first HX50 fuselage. Now, we promised you that we would build you a proper helicopter, and this is a proper helicopter. We've remained true to the concept, we've remained true to the beautiful look, the streamlined lines. We've managed to use composite processes that allow us to deliver this fuselage at a game-changing price point, and it's delivering on everything that we accept. Now, this infusion isn't perfect, and I'll talk to you through all of those things in a moment, but first, let's just have a look at this helicopter for one moment. I mean, the first thing that you notice is the sheer scale of the thing. From nose to tail, it's just under 10 meters, well, just over 10 meters if you go to the tip of the tail. So it's much bigger than what you're used to. It has the proportions really of not far off what you'd expect from an A-Star. If you come and have a look inside the cabin here, one of the first jobs that we've got to do with this fuselage is what we call a human factors mock-up. So you can do everything you want in virtual reality and augmented reality and modern fancy CAD systems, but nothing feels like sitting in something and feeling what that pillar or that view angle actually looks like, making sure you can move the flight controls, making sure that you can see the displays and that you can work the iPad. And so what we've done very crudely before we tool up all of these additional composite components is used a lot of rapid prototyping hardware just to produce the center console, rapid prototype stick heads, representations of the monitors and the wolf's head that gives you the down angle, just to prove that all of these things work the way we intended them to. And we'll talk through all of that in a second. The other thing that you notice as you come round the front, well, the thing you notice from the side to start with is the sheer volume that you've got within the cabin. The space that we've got in there is basically the same sort of size, even if it's a slightly more generous than what I have in my Range Rover. And so this is a really capacious and luxurious cabin. And then when you come round to the front, you can see the fantastic view that everybody's afforded. These are the windows that we made ourselves. These are our tools. Again, only prototype tools, so the finish on these isn't perfect yet. It's again just to prove that this is the way that we're going to make the windows more than anything else. And the space that we've got left here is, as I've told you previously, for your landing lights and then the presentation of the badge underneath the glazing. So Milan, if you just go back round that side for a second, and we'll talk through the interior. So there was a lot of discussion in the early days about the collective in HX50, and as I said to you before, and you can see it here in the way that it's implemented. The collective works in just the same way as it has on many helicopters, and just the same way as it's been implemented on certain other light helicopters and certain other bigger helicopters as well. So the action is perfectly conventional, up for up and down for down, but it's nestled neatly in the armrest so that your elbow can rest on the armrest here, and your hand moves conveniently for the puck that drives the integrated pilot interface. We've also got the actual switches. Again, these are only rapid prototyped covers, just to check the size and the function of them. But we've got the start switch, so the power switch, the master battery. We've got the avionics master, the start button, and the nav lights, and then the fuel cutoff there as well. We've got that's a a full-size iPad, so that's the very big one. And then these are full-scale representations of the DigiCockpit interface. And again, you probably won't appreciate it over the video link, but when you're sat here, these screens are very low, so that down angle there to your eyes is just a little below 20 degrees for most people. So you're still able to see essentially anything up to about 2 meters in front of you on the ground. And the view down through the chin windows is also really, really helpful and much akin to what you will have been used to previously. And of course, one of the beauties of having the center console, as well as the comfort when you're flying, is the fact that there's room for creature comforts in the cabin, like a bottle of water if you get thirsty while you're flying. There's seldom anywhere to put that in helicopters that we're all used to. So if we take a look in the back of the fuselage, again, it's an enormous space that we've got back here. And the cabin bulkhead sits here, so your rear seats are mounted on this bulkhead, slightly higher than the front seats that you can see here. And this enormous volume between the aft cabin bulkhead and where the baggage bay starts is the fuel tank volume. So 575 litres or 175 US gallons of fuel as a maximum capacity in there, in bladder tanks trapped between those two bulkheads and the undercarriage wells. And what you can see at the top here is the engine bay, and you can see how we've sunk that down into the roof just to keep it out of the wind and to keep that sleek exterior profile that gives HX50 its performance and its intended cruise speed. So for those of you that like active outdoor pursuits and fancy holidays and such, it's important that this proper helicopter that we've made for you will support your lifestyles. So I know we've got a number of golfers in the customer community, and just to assure you that getting multiple sets of golf bags in the baggage bay won't be a problem. And of course, for long, thin things, you can load all the way up into the bulkhead for the tail boom. And then similarly, this is a full-size suitcase, and you can easily get 3 of those through the door and back again, and there's plenty of room left on the other side to spare. So this really is genuinely a very, very large helicopter. The other thing I would say about this fuselage as well, and there's a little video circulating of me and my wife picking it up, just the shell before we put all of the HF mock-up stuff in there is just 35 kilos at the moment. That will get heavier as we put all the other internal panels and things in there, but one of the advantages of carbon fiber is it is really, really light. It has a really fantastic strength to weight ratio that allows us to create everything, really. It allows us to create the Gucci looks, the aerodynamic form, the strength and the crashworthiness, all in a single package that, with these techniques I've outlined today, you can manufacture more cost effectively than ever possible before. Some of the other things that we've been looking at on the HF mock-up as well are things like door handles. So I know it's not something we've talked about a lot before, but one of the things that the guys have been trialing, again, just very crude rapid prototypes at the moment, but the implementation of a Swandle-style door handle where you just pull and then open it and it fits flush with the cabin door. And you can see that height is accessible for everybody from the 5th through to the 95th centile. And then again, similarly, this will be a chrome feature that sits in the top of the door rolls, both in the front and the back, an upward facing door handle that allows you to open and close, gives you a clear indication if the door's not latched properly, and locks down like that, all very discreetly packaged in the doors. So that's essentially an overview of the touchy-feely stuff about the first fuselage. If we talk briefly about what's gone into this technically, this is genuinely the very first one that we've ever made. And so, as you'd expect, it's not perfect, and we never intended it to be. The surface finish that you get on the carbon is entirely down to the quality of the patterns. The pattern surface finish transfers to the mold, and the mold surface finish transfers to the part. This whole exercise has really been about proving we can make this cost-effective fuselage in one piece. So we've skipped a lot of the steps in creating high polished finishes on each of those, just because we don't need them for what we're doing here. So don't worry about the surface finish. We'll refine that when we cut the tools for the flying prototype, which will embody a few few changes and a few things that we've learned along the way. I think the other thing, and we went through exactly the same process with the third scale model, is in order to get sharp definition on edges, so these recessed panels here where the doors fit flush to the cabin to create the aerodynamic performance that we want, in order to create those sharp edges, we have to take what we call a carbon fiber bootlace, pack that into the tight corners in the mold, and then lay the carbon fiber over that so that we've got something for the resin to infuse into. We didn't do that on these purely because we weren't interested in those edges. It's purely about the overall infusion strategy. And so there's a bunch of things like that. Similarly, with we haven't put the lightning mesh in the roof of this one, and we haven't put any of the reinforcements in this one either. That will all follow on the second fuselage, which we'll be doing early next month. The other thing that you notice very quickly when you're walking around the fuselage is the sheer stiffness of the panels. I mean, even though this fuselage is incredibly light, this area here, which is a representative laminate, is incredibly stiff compared to what you're used to in conventional metal-like helicopters, and that will only stiffen further when the bonded-in bulkheads that create the fuel tank and the floor get attached. And so that's what comes next as we take this and progress it now towards something that we can put on the structural test rig and push and pull to prove that it meets all of the structural requirements that we need. So after just 8 months, we've gone from not having a composite facility at all to building the facility, recruiting all the staff, developing all the processes, and now delivering the very first HX50 fuselage. So there she is, fuselage 1. Okay, so what does all of this mean for us? So essentially, what all of these processes mean and what all of this effort and all this vertical integration stuff means for both us, for HX50, and for our General Aviation 2.0 movement is this. We can build the aircraft that people want. We can make it look the way you want, we can make it perform the way you want, and we can deliver it at a price point that you can afford. Okay? These processes fundamentally allow us to make a step change in what you've been used to, because we can deliver both the performance and safety at the price point. That's what all of this effort's been about, and now it's just work. Now we've proven we can do that. Now we just have to complete the process. So let's move on from the airframe briefly, though I'm happy to answer any questions you've got on it a little later. Let's talk about the drivetrain and the engine for a while. So while there's been a lot of focus across the company on the composites and the production of that first fuselage, the GT50 engine has been progressing equally quickly. We've now got a mature new gas generator design. So this is the single stage compressor turbine, the modified combustor, and all of the changes that's been involved there to make a simpler, more efficient, lighter, and easier to manufacture engine. We're currently optimizing the new annular combustor that will run on both conventional and synthetic biofuels, and we're just in the final stages now of completing the aerodynamic optimization of that single stage turbine. The manufacturing preparation for all of these components is now underway. I'll show you in a little while how we've been developing bearings and turbine blades and the fabricated metal components. And with all of that, both the performance targets, the life targets, the cost targets are all on track as we stand here at the moment. So let me introduce you to the latest version of the GT50 engine. So the engine has a simple modular construction. It's got an extremely low part count, a very, very modern design, and a fail-safe architecture. So this engine conforms to the very latest standards of JAR Part E and FAR Part 37, so it meets all of the fail-safe architectural requirements and probabilistic failure requirements that are now required, that weren't necessarily required when these engines were first, when similar engines were first developed. And we've also got a modern approach to manufacture, both the CNC stuff that you've seen before, 3D printing and a modern approach to the metalwork and the fabrication that we've introduced previously. And above all else, with it being modular, it's very, very simple to maintain. So the modular layout of the engine has a high-speed motor generator unit on the front, the inlet module, which contains a bevel gearbox, the de-icing and the inlet geometry, the gas generator module, the power turbine module, and then the drivetrain with the exhaust bolted on the back. Just those simple set of modules are all interchangeable and easy to maintain. If you look at the new gas generator itself, this embodies the very latest air-blast atomized fuel injectors. So that soot characteristic that we're all too familiar with, where helicopters will throw soot and oil deposits down the boom, the way that we retain our oil and the way that we inject and burn fuel within this engine is much more modern and should minimize that effect to a very substantial extent. The modern combustor also helps with that and gives the lowest possible emissions for this class of engine. And then on top of that, again, this gas generator module is designed to be simple and easy to manufacture, assemble, and maintain. If you look closely at the arrangement of the engine, what you can see is our fuel nozzles are actually removable from the outside of the engine, so they can be changed and checked and modified. The fuel manifolds can be accessed from the outside as well. You can see the shape of the new annular combustor in the exploded diagram there, as well as the diffuser, the impeller, and the inlet modules as well. So all of these things are now maturing to the point that early in the new year we'll be able to produce this. Now, one of the main barriers to prototyping modern gas turbine engines is the fact that the turbine blisks, the turbine wheels themselves, require very, very complex precision casting processes. These components are extremely sensitive to flaws and inclusions, all sorts of things that you would normally expect in a casting. And it takes quite a while to get those casting processes to work, and quite a big investment to be able to do that stuff in-house. One of the things that we've been doing to enable us to process through prototyping very quickly and avoid the need for expensive tools for waxes and various other things is to look at extensive machining of these superalloy materials for short-lived prototype components that are there to do primarily the balancing of the engine and the performance matching and the tweaking of the fundamental aerodynamic and thermodynamic performance of the engine. So Mark and his team have been busily taking the actual superalloys that we need to use to produce these components and producing turbine blades in the correct materials. We've shown you previously that we can produce the actual turbine wheels. We've got the work holding and the fixtures for that. And over the last few weeks, we've perfected the process of machining these things from solid. Now, this isn't a production process. This isn't how you'd make them in production. But what this does do is it allows us to make prototype blisks very, very quickly. For the non-rotating components, it's much simpler because we can 3D print them, we can cast them, and their duty is a lot less arduous. But for these high-speed components, where they're very, very tolerant to defects, these have to be very high integrity. So we can now buy forged stock of this material, machine them from solid, and demonstrate the performance of the engine at a much more cost-effective and practical way. In addition to that, we've also been doing some further refinement of the in-house compressor. So we've previously shown you the final aerodynamic design of the compressor, and we work with our tooling partners to optimize the machining parameters and the tooling types, the tooling inserts, the feeds and speeds, all the things that you need to do to optimize it. This has now come back home, and our own CNC team have been optimizing the cutting strategies and the way that we manufacture this in-house to get the cycle times down to the absolute minimum, so that we require the smallest number of CNC machines possible and have the shortest possible cycle times to make these components that drive the cost of the engine. And what I can show you here is this is actually the very first the very first titanium compressor that's been made in-house by us using these new processes. So this is the blank. All of the turning ops, the labyrinth seals, the curvix have been completed, and this is going on to the 5-axis to have its blades cut either tomorrow or Thursday. So big progress on that front also. So we're in a position now where not only can we produce the prototype titanium compressor, but also the turbine blades, and very shortly the sheet metal work that's required for the combustor will follow suit. So the combustor is an area that is crucial to the design of the engine. It dominates the stability of the engine, it has a big impact on the efficiency of the engine, and it has a big impact on the reliability of the engine. We've been using the very latest computational methods to optimize the way in which we spray the fuel, the way in which the fuel burns within the combustor, optimize the metal temperatures and the cooling flows to keep those metal panels down at temperatures that they can survive, and all of the time doing that in parallel with how we physically manufacture these things. So 5-axis, CNC laser cutting, laser drilling, and laser welding, and then making the simplest possible embodiment of this combustor that we can possibly do to deliver a cost-effective combustor to go with the other components within the engine. In other news, you're aware that we've been working on our in-house bearings for some time now, turning and then grinding the internal bearing races, the external bearing races, the internal bearing races, and then the cages. So this is a cage. We produce it in one part, drill the holes and then split it. All of that work has been completed, and a few days ago we produced the very first internally manufactured Hill bearing, and this is actually an early version of the gas generator bearing. So this is actually the most difficult one to manufacture in the entire engine. This thing spends most of its life at 50,000 RPM, which is an incredibly demanding duty for a bearing. And so that's the first one out. Again, there's a bunch of things that need to be refined before we're ready to test this, but as of today, we can produce our own bearings. And so that's another big step forwards on our route to getting GT50 on the bench. You've all followed the progress that we've made on manufacturing our own in-house gears to drive down the costs of the main rotor transmission, the engine transmission, and the tail rotor transmission. You've seen us master the gear manufacturing that you can see here. So the key elements of the main rotor gearbox, the spiral bevels, complex gears, complex splines. The very next step is then to harden these teeth and complete the hard machining so that the teeth can deliver the life that we need from them in service. Now, this is another example of why vertical integration is so important to getting costs under control in aerospace, in particular in general aviation. The next step in this whole process, as daft as it sounds, is copper plating. So we create a blank that you've seen before. You've seen these things all looking shiny and freshly cut in steel. They then have to be sent away to be copper plated. And the reason for that is when we come and heat treat gears, we only want to heat treat the teeth. Okay, we don't want the structural part of the gear and the root material to be hardened, because if it was, it would become brittle and it would have a poor fatigue life and a poor fracture toughness. And so we have to cover the rest of the gear in copper plating so that when we put it in the furnace and carburize it, this material isn't affected by that process. And that simple process has essentially taken, with a third-party subcontractor, 3 months. So from the time our bits were ready, for a process that takes minutes to complete, we've been waiting around for 3 months to get those done. And in that same time period, I've been able to recruit the people necessary to develop these processes in-house, develop the processes, and over the next few weeks on the run-up to Christmas, we'll be doing this for the first time in-house to avoid those kinds of things. And when you think of all the little things like that that we have to do to make these things, if everybody can create a 3-month delay in the things that you do, you've got no control of your time scales. And that's another example of why vertical integration isn't just important for the big things when you're in production, it's actually important for controlling your time scales in-house while you're going through development. And this is another great example of just how much impact that's had on our business. Okay, so let's briefly talk about the digital cockpit. So one of the areas that I haven't provided much update on recently is how we make HX50 an incredible helicopter to fly. And a lot of that comes down to an area known as flight dynamics. And this is how we manipulate the aerodynamic surfaces and the flight mechanic characteristics of the aircraft to make the aircraft fundamentally stable, and then how we augment that with stability augmentation and intelligent control. Now, over the course of the last two weeks or so, we've been working with our flight dynamics team to start developing the flight dynamics detailed models of the aircraft. Now that we've refined a lot of the mechanical design, a lot of structural design, now we've established the inertias, now we've got formal aerodynamic design established for the aircraft, and that then allows us to develop the way that the two-axis autopilot will deliver stability augmentation, the altitude, heading, speed and navigation hold functions, and the haptic feedback to provide a degree of envelope protection, haptic power management, and then also for those of you that will opt for the four-axis autopilot, how we provide additional support to make the aircraft even easier to fly. One of the things that we expect to make the biggest difference is the active yaw control. So to a substantial degree, decoupling the impact of the collective on the pedals and providing stability in yaw to gusts and winds from all directions. In addition to that, the four-axis autopilot will give you simultaneous control of altitude, speed, heading or nav, and yaw. It can hover hold. It gives you essentially cruise control in every aspect of flight, and then much more extensive envelope protection, including VNE, rotor RPM control to protect against overspeeds, vertical speed limits, vortex ring state protection, and protection from incursions into the height velocity envelope. And on top of that, auto-rotation assist. Now, all of those things are actively now being developed now that we have the user experience developed to a point and the mechanical and structural elements of the aircraft to develop to a point that we've got the inputs to develop out those algorithms and the software to deliver it on the DigiCockpit. So onto the DigiCockpit for a moment. One of the things that we're focused on at the moment, and Eric in particular is focused on, is the integration of all of the peripheral equipment into the DigiCockpit and writing certification grade software to implement all of these things. We're only going to do this once, so get those things implemented, implement them properly, and that's a very tedious process. So it's one step forward and another step back sometimes. But that's all being done at the moment. We'll take you over and have a look at the avionics test bench, and we can see Eric and how he's getting on. In addition to that, we've upgraded the avionics test bench to include actual flight controls now. So a lot of the workflow and the man-machine interface between the intelligent technology that we're building into the autopilot can be tested, integrated with the flight simulator, integrated with the flight controls and the user experience. And all of that is currently being done right now as we evolve through software development. In other news on the DigiCockpit, it's really important, as you've seen with the HF mock-up that we're going to be building in the first fuselage, that we get every single detail right about this helicopter. It's no good at just looking good. Every single part of it has to be fit for purpose, has to be properly optimized. So we've been doing a bunch of trials on screen brightness, making sure it's dim enough at night and bright enough in the day. And now that we've got the glazing fitted on the fuselage, we'll be testing the screens for glare in the roof windows, the side windows, the screens, developing the right balance of coatings and anti-glare, anti-reflection, generating the right amount of light that's being allowed to come into the fuselage through the tints. We're doing some work with mock-ups of the cyclic and the collective stick heads so that they work properly and interact correctly with the DigiCockpit. And even silly things like button heads and switch heads, all of those things need to work right and feel right. And so that work's going on right now, including things like PUC optimization and the user experience usability. So let's go over to the avionics test bench and we'll have a look at some of those things and the work that Eric's doing. So I pointed out previously that a lot of the hardware that will actually be on the aircraft is installed on this rack and properly wired in. These are the actual switches. They're only rapid prototype heads at the moment, but these are the actual switches that will find their way into the aircraft. These are the switches that find themselves onto the cyclic and collective. And then we've got the circuit breakers, contactors, power supplies, and all the other elements that go into it, all being driven by the user interface. The target hardware that we've shown you before, at the moment the system is running on a PC while we develop the user interface and the software, and then it will be ported down to inexpensive target hardware that will go onto the aircraft. One of it might seem trivial, but one of the things that we have to make sure that we get right is that every way that you interact or touch the aircraft needs to have a premium feel. So even silly things like the feel of a click or the notchiness of the puck as it indexes around the encoder is really, really important. And so we've built a bunch of samples with different stiffnesses of encoders on the back so that we can get that just right. The stick heads, as I mentioned earlier, have been rapid prototyped using a simple rapid prototyping machine just over there. And one of the things that we've discovered immediately is that we need to tweak some of these angles slightly to make it easier to get your thumb round to activate some of the buttons. And the feel of these can be optimized slightly as well. So very simple tricks to make sure that when we spend money tooling these things and build the real things, they feel as you would expect them to. If we just have a look at the engineering simulator that we've got over here for a second. As we've shown to you previously, this is currently feeding the DigiCockpit information via an X-Plane simulator so that we can work through all the nuances of the user experience and the user interface. And one of the things that we've added is flight controls now, again, so that we can look at haptic feedback, so that we can look at control sensitivity, so that we can look at control algorithms when we replace the X-Plane environment with the flight dynamics model that's being developed right now. So all of that works ongoing. And Eric's busy implementing the control software that uses that interface to drive those boxes up to certification levels. Are any of the demos ready at the moment, or still playing up? Okay, so that's one for next time then. So yeah, that's the DigiCockpit and where we're up to with that. Okay, so one of the other areas that's receiving a great deal of attention at the moment is the production. So with the large demand for the aircraft, that's putting a significant pressure on us to make sure that our production facility is ready and that it's capable of scaling up to deliver the number of helicopters that we need to in the time frame that we need to. So in parallel with all of the activities that are going on from an engineering perspective, we've been pushing through all of the planning applications that are required. There's 3 in total. They've all gone in and been submitted and are now awaiting a decision from the local government. We've signed an exclusivity agreement for the site at Cresswell. So we have a site waiting to build this building subject to planning permission. We've got detailed design underway for the manufacturing system. So all of the cellular manufacturing that needs to go on for the precision engineering components, for the composites, the assembly, and all of the other stuff that needs to go on to produce the componentry, and then the full assembly process, including the build school. That's being driven forwards at the moment. And we've also now started the procurement exercise for the major chunks of production equipment that we need to deliver all of these processes in-house. In addition to that, we're currently working up a deal where we're planning to host the Stoke-on-Trent Air Ambulance at the Hill global headquarters. One of my core philosophies is that for a business to be successful, everybody needs to be successful, and that means the people that work for us, our customers, and also our neighbours. The Stoke-on-Trent area and the surrounding moorlands villages have struggled for many years to gain access to an air ambulance. In the UK, air ambulances are not funded by the government and they're not funded by companies, they're entirely funded by charities. And so we've offered to host the air ambulance. We're not paying for the air ambulance itself, but we've offered to host the charity at our facility and provide the heliport facilities they need, the fuel services they need, hangarage, flight crew and ground crew facilities that will dramatically cut the response time for emergency medical services for people in and around Staffordshire Moorlands and our factory site. There's much more information going to be pushed out on this over the coming months, but I thought I'd share that with you tonight, as it's genuinely good news for everybody in the surrounding area. So, with all these exciting things going on within the company, it should be no surprise to anybody that sales remain strong. And as I sit here at the moment, we've currently sold 692 helicopters with 574 X models and 118 C models. The current pricing that we're offering is the list price is £595. We're offering a £119 discount on the next 3 serial numbers, giving you a current offer price of £476. That's only valid for the next 3 serial numbers. That will ratchet up by £1,000 every 3 serial numbers we sell now, until the point that fuselage flies or we get to serial number 1,000. So on that, I'd like to thank you for your attention, and I'll do my best to answer any of your questions. Thank you.
Very good, Jason. Wonderful. That was a very exciting update on the progress of the whole program. It's amazing to see where we're at today and where we're going to be at in the coming months here. Very, very neat. So we've got lots of questions that have come in. I just want to remind you guys as well, if you haven't posted a question yet in the chat, feel free to go ahead and do that now. And we're going to go over hopefully all of those today. So the first question, Jason, is one that's come up in the past again, but see if there's any updates that you can give us based on where we're at with the HDC and everything. So the question is there any plans to deploy flight simulators, flight training simulators, and allow the buyers to use those simulators while they're at the assembly factory? And then as an option for customers waiting their queue, would we be able to use that in something like Microsoft Flight Simulator? They say they're anxious to see the HX50 fly.
Yes, and yes is the simple answer. So the one thing that I wanted to be sure of was that the flight dynamics model was representative of the aircraft and how it was going to fly. And to do that, there's a whole bunch of stuff been going on that I can't talk about yet to do with the rotor head, because there's a bunch of stuff that we haven't patented yet. But there's some profound things that have been finished in there now that allow us to populate a flight dynamics model, and that's what's allowed us now to trigger the autopilot development and a bunch of other stuff. But that's the same stuff that will allow us to provide the flight simulator developers, both the hobbyists and also the commercial guys that are building training aids, with everything they need to produce a simulator that's representative of the way the helicopter will fly. And I'm going to use this as a justification. It's not really a justification, but we've been using another aircraft that I'm very familiar with flying as the flight dynamics model on our DigiCockpit simulator up until now. And Eric flies the thing absolutely beautifully, and me, with my hundreds of hours, had a first go in it the other day and couldn't keep it upright. You know, so if you're deprived of some of the senses that you're used to flying with, and the flight dynamics model isn't quite right, none of the things that you're used to will work quite right. So I'm very keen that whatever we put out there is representative of the actual aircraft. So yes, it's coming. For the hobbyists, we'll be very open with the information so that we can get X-Plane and Microsoft Flight Sim up and running and get the aircraft out there into those environments, because I think that's good for all of us. As a company, we will push very hard with simulators for training, exploring failure scenarios and parts of the envelope that you'd never want to take a real aircraft into, pushing people into IMC to show them just how dreadful it is. All those sorts of things I'm really keen to do with simulators, and I'm really keen to deploy that kind of quality of training aid at a low price around the world, so all the distributors and training schools can have it at their disposal in the future.
Awesome.
All right, next question comes from Daniel Shepley. He was in our last Q&A, and he says that his last question was possibly misunderstood. He wants to present it again.
Okay.
And it is, my question was on the GT50 turbine engine. Will it be certified for standard diesel, not biodiesel? Biodiesel compatibility might be interesting, but not particularly useful for most of us, the owners. So he wants to know, will it be certified for standard diesel?
So the answer to that is probably not. Now, the reason for that is the engine will run on those fuels. These engines will run on a wide variety of heavy oil fuels. The challenge isn't getting them to run on it, it's proving that you don't do any damage to the engine over extended periods of time. So we will approve the engine for a wide range of conventional jet fuels, and then we will approve the engine for a wide range of biosynthetic jet fuels. Now, they are very similar to conventional kerosene based fuels. They're essentially a drop-in replacement, and we will be involved in putting a supply chain in place for those as we go forwards. I think that's absolutely vital for the future of private flying and for the future of the C model. And in terms of alternative fuels, conventional road diesel, off-highway diesel, and other fuels like that, if enough people wanted to do it, then we would do the qualification runs, but it would probably have an impact on the warranty that we could offer. Because if you think of the testing that we're having to do on the GT50 for the approved fuels, it's thousands and thousands of hours to show that there isn't some nuanced behavior that shows up late in the day and causes us reliability problems. So to duplicate that for any number of fuels based on a small pocket of users around the world, it just isn't a practical proposition for us. If there's enough call for it, if there's enough users will do it, then we'd happily consider it. But at the moment, it's conventional, widely available fuels, and they're bio alternatives that are just around the corner.
Just before Misha presents the next one, actually, Misha, just before you present the next one, Gonzalo, also from Mexico, he says that jet fuel is difficult. Can diesel be used on the XS50? Just for that, that more and more person looking for the diesel on these questions. But go ahead, Misha.
Yeah. Well, one of the things that we can do, and this is one of the unique advantages of our approach, is we can poll the user base via the app. There's a bunch of other things that I want to do that for anyway, but we can do a poll to see how many people really are interested in these fuels. We can have a look at whether it would be viable to do that. We obviously want the usability of HX50 to be maximized wherever it is in the world. And so if there are genuine needs like that, please do tell us and we will listen.
Excellent. That's really good. Another question from Daniel. He's asking about shipping. So can you just explain a little bit more in detail the shipping process as far as what has to be disassembled for creating it, and then particularly on the other end, when you're reassembling it, does it have to be a trained AMP that's going to be reassembling the aircraft, and what does that assembly process look like?
Okay, so the aircraft itself is very modular, as you've seen. So the aircraft tail boom is removed, the horizontal stabilizer is removed, the cowlings around the top are removed, and the blades are removed. At that point, it will fit on a transport frame into a 20-foot shipping container. the boom, the airframe, everything. All the other systems remain attached. At the other end, yes, you will require a qualified A&P mechanic just to put the boom, the stabilizer, and the blades and cowls back on and do an acceptance for you. But all of the test flying, all of the approvals will be done with us in the UK before it leaves. So it's not a dissimilar process to accepting any other aircraft.
All right, and Don is asking, how many gallons does the fuel tank hold?
175 US. So that's 5 hours at maximum continuous power.
Excellent. Nice and easy on that one. Jonathan is asking, is there anything being done, this is an interesting question actually, with the carbon pieces that are being cut out from the monologue after the molding? And he says, hill luggage perhaps?
Well, there's a very good technical answer to that. It's perhaps not the one you wanted, but in the production version of this airframe, rather than those panels flowing with the curves of the aircraft, we'll actually make those slab-sided flat panels, and we'll cut coupons out of each of those from each airframe. So we can test the integrity of the carbon fiber on every airframe in a bunch of different directions. So it'll form part of our quality control procedures as we build the airframe. And over time, you need to do less and less of that. But certainly at first, every airframe will be subjected to very, very extensive quality control procedures as we produce them. So sadly, we need those, and those will be kept by us to verify that your airframe did what it should have done when it left the factory.
All right. And Preston is asking, what will be the lifestyle or environment where you will recommend between wheels and skids?
So I've always, and everybody knows that I've always been a massive proponent for wheels. The aircraft is significantly faster on wheels. The skids look pretty cool as well, but unless you're going to be landing belly deep in snow or routinely landing in rivers, which I wouldn't necessarily recommend, then or landing in really, really soggy, muddy fields, then for any other environment, I really think the wheels will work better for you. I think the flexibility of handling the aircraft on the ground is much better with wheels. The HeliMove stuff takes that to a new level, and handling the aircraft when you're away from home as well. I also think wheels help you with training. You can practice your run on auto rotations. It just becomes like landing an aeroplane rather than dragging the poor thing down a runway. So yeah, I'm very much for wheels, and unless you want to land in swamps or snow, you don't need the skids.
Excellent. Next question is from Ben. When does the airworthiness start? Is the fuselage design finalized, or can it be refined beyond the airworthiness testing, etc.?
Once you've done your airworthiness approvals, that's it. It's locked in. The whole process, the design's locked in, the supply of materials is locked in, the manufacturing process is locked in. You can't change anything unless you want to go and re-qualify things that are touched by that change. So the airworthiness process started in about 2015. And has been going ever since. It ramps up, and the engagement of the authority ramps up. And at the moment, there's two main focuses within the company. We're checking and proving and documenting all of the compliance for each of the requirements in the airworthiness aspects of the design, proving that we meet all the safety cases, documenting all of that. In parallel with that, we're working on the organizational approvals that we need to do in parallel to be an approved design organization, an approved production organization, approved flight test organization, and so on and so forth. So all of those things have been going on for a while. It's not a fast process, hence why it was started a long time ago. And it's not a linear process either, because you have to be sufficiently developed as an organization. The design has to be sufficiently developed before it's worth involving them. Otherwise, it just slows everything down. So yeah, that's been going on for a while now.
And before the next question, we have a comment that is worth sharing from Peter. He says, from experience in high-tech carbon composite components intended to performance vehicles, this is extremely impressive. Congratulations, and I'm really impressed by your honesty, transparency, and pragmatism, and the evolution and nature of the manufacturing process. So it's a good comment there. from somebody that has experience, Jason, is worthwhile sharing. Next question is from Camille, which is, if the infusion process leaves a dry area, can you manually apply the resin after the carbon fiber comes out of the mold?
The simple answer to that is no. So during the infusion, there are some interventions you can take to correct an infusion or a dry area. But if you get those problems, the infusion process isn't working properly, the process won't be repeatable, and it would be a disaster. So you don't go and fix problems like that. You fix the problems with the process. So from our point of view, we need to control temperatures a lot better. We can optimize our infusion strategy, where we put the feeds and where we draw the vacuum and all that sort of stuff. But the big thing for us is getting the right temperature everywhere at the moment. These big molds and these big patterns need very careful temperature control, and then the oven needs very careful temperature control to deliver that. Once we've done that, it'll be an extremely robust process. The other big area is vacuum integrity. You know, as you've seen from the patterns and the molds that I've shown, they look like they've been through a few wars at the moment, because we've tried various things and iterated and improved various parts of the processes as we've gone, all on the same hardware. And there comes a point where you need to take what you've learned and just do it again. And we've been through that loop once with the molds, but we're getting to the point that when the last of the design features are baked into the fuselage, we'll cut a new set of patterns and molds, and those will be our first attempt at production grade patterns. And assuming that goes to plan, we'll just make 10 to 15 sets of those to support the production process.
Excellent. The next question is from Johan, and it says, will the carbon fiber be lined with Kevlar to prevent shards if in case of a crash?
There's no plan for that at the moment, no.
Okay.
Okay. And David is asking, what planning has been considered for shipping? Will the helicopter be shipped in the 40-foot container?
It'll go into a 20-foot container. Hang on, wait a minute.
That's correct.
Yeah, that's correct. Sorry.
Tail boom out and blades out.
I hesitated because we changed the split line a little while ago between the tail boom and the monolage, and we checked that it would still go into a 20-foot container, and it does. So yeah, it'll go into a 20-foot container.
Excellent.
All right, and updated check that 20-foot will still do it.
It does. It definitely does.
Jace Blair is asking if you could sit in airframe 1 for us.
I can't, because it's just resting on that stand at the moment. So if I sit on it, it'll fall forwards.
Maybe sometime we can have that all set up so we can.
Yeah, we'll do that. We'll do once we've got that HF infrastructure fitted in properly. There's a floor and there's some bulkheads and things that have got to go in yet. Once that's in, we'll do that, and we'll also do a picture for people of me lifting the thing up, because we can, because it really is that light.
Yes.
All right. Carl is asking, seems like a lot of work and time for making the fuselage. The running of tubing and making sure all will be sealed. What is the plan to reduce the time to manufacture?
That's easy. The time to manufacture will be about a day. You've got to remember, we're developing all of these processes, and the things you do to develop processes don't represent what you would do in production. So we're not going to CNC cut fabrics until we've developed what shape they need to be and we've templated them. And we're not going to make bespoke pre-made bags to vacuum bag the thing, or pre-made manifolds and hoses, until we know where all of those things have got to go. So all of the steps in this process productionize really nicely. And sort of resin transfer molding and infusion are the processes that they use to make high volume composites. That's why we went down this road. So don't worry about that. The infusion happens really quickly. The kit cutting is a proven technique with off-the-shelf hardware that we can buy, and things like bags and pipes and manifolds and all of that sort of stuff. There'll just be a standard pre-made set of stuff that we use for each of the fuselages. We'll be able to make one of these fuselages in one 24-hour period, and then we'll probably need another night cycle to get it painted. It's a really fast process. Not the way we did it the first time, but it will be.
Alejandro from Chile has 4 questions that I'm going to pose to you kind of rapid fire, and we can go over them as you wish here. So the first one is the maximum load hook weight, and what is the estimated maximum takeoff weight with external and or ejectable load? Can you comment at all on that? I don't know if you can give exact numbers at this point, but
do I want to tell you that now? It's a lot.
That's a big question. Because there's been some development on that.
Yeah, what have we declared publicly, Misha? I can't remember. Was it 1850?
External load, we haven't declared anything different than the regular external, or than the external, or the gross weight.
Well, so let's just say it with 100 kilos of fuel and a 100 kilo passenger, it'll lift 800 kilos on the hook. And I've got evidence in front of me that tells me it'll do more than that, but I don't want to declare it till I've physically done it. So yeah, the external load capability is amazing.
Okay. This next question, I'm not sure that I fully understand. It comes, the question says, it comes or you can put a short cable. So I'm not sure if that's for short lining. That one I'm not sure I understand.
So essentially what we're providing is the attachment on the body of on the underside of the fuselage, and then the implements to be able to connect that to your line equipment. So the rest of it is the customer's responsibility.
And the next one, I actually haven't heard of these two terminologies. I think I understand them, but it says, how is the control of the flight hours considered? So is it centesimal or sexagesimal?
I think it's 1 hour and 35 minutes, or 30 minutes, or 1.5, basically.
Right.
That's the.
I honestly haven't considered that yet. I think it'll just be in line with what the current practice is in light helicopters. So decimal hours to 2 decimal places.
Right.
So it is centesimal. Yes. Yeah. It is by the decimals.
Mm-hmm. Yeah.
And he's asking, this is something that we can't give a definitive answer on at this point. It says, when can you estimate that you're going to be able to reserve an HC50 without the requirement of having the HX50? Do you want to comment on that at all right now, or no?
No, I don't want to comment on that just yet. It'll be a little while yet.
Yeah, expect that to be next year, I would assume.
Yeah.
Mm-hmm. And Steve is asking, could the engine be run on new SAF fuel?
Yes, fuel? Absolutely. As I said, when we open up HC50 to the general public, that will come with a very wide-ranging offering in terms of how we're going to make light helicopters more sustainable. And our view for sustainable short-term aviation, whether it's commercial airliners or smaller scale aircraft, in fact it's more applicable to us, is that synthetic fuels are the way forwards. It's the only thing that will work in the short term. I don't believe that hydrogen's viable, and I certainly don't believe that battery's viable. So you have to use synthetic fuels, whether they're bio-derived or some other clever stuff that hasn't been developed yet. Sustainable fuels are very much the way we're going, and that is how we will generate a sort of net zero CO2 output from our operations.
Excellent. Carl is asking, the inlet casing looks connected to the bevel gearbox. This looks good for strength, but will it create an issue with the heat transferring to this gearbox?
No, is the simple answer. I'll take that one offline with Carl. For lots of reasons, no, it won't.
Okay. And King is asking, is this model reliable enough to sustain itself in harsh conditions like Africa?
Yes, definitely.
Okay.
And part of our
places are harsh.
Yeah, part of our development process is going to be to send 2 of the prototypes to some of the harshest places on Earth, so that we can try and break them in those locations. We'll be reaching out to our clients in those areas to draw on their experience of how aircraft have suffered in those places in the past, so that we can reproduce those conditions and make sure that the aircraft is hardened to them.
Okay. And this next question is from Greg. It says, can you please go into some detail on the fuel system architecture? What types of engine-driven and airframe auxiliary pump, fuel pumps, will the aux pump be continuous duty? This is coming from a customer of ours that has had a couple unfortunate incidences with his previous aircraft. So.
Yeah, I should talk to that first. I have received your email, Greg, and I will respond to it. I just haven't had a chance yet. The architecture of the fuel system is actually up in the air at the moment, because we're driving very hard to either, well, we have to meet the latest standards of the Airworthiness Code, but we're looking at a couple of areas where we might choose to exceed them. So we've got a range of engine-driven pumps and electrical-driven pumps, and we're looking at the level of redundancy that we want right now. So that's a very hot topic. I don't have a definitive answer for you because it's in a state of flux at the moment. You will be aware that HX50, because of the size of fuel and because of the payload that it has for the size of the aircraft, has a trimmer tank in the nose. So our fuel system is slightly more complex than you will have seen on previous generations of light helicopters of this size. So we carry an amount of fuel in a forward tank that trims the fuel CG. So there's a bunch of additional pumps that deal with that and make sure that your fuel CG is where you need it to be. So I'll come back to you with a more definitive answer on that when we finish the work that we're doing right now.
Jonathan is asking, will the production versions of the Blisks be machined from in-house casting once the CNC machined versions have been optimized? Are the castings going to be also in-house canned for inclusions?
Yes. So one of the really interesting things, I don't know if it was on this one. Yeah, it's on this one. I don't know whether you can see it or not, but with it, this is a piece of cast alloy, and so this was never designed to be machined. This was designed to be remelted and cast. And the problem with that process is that the castings are full of microcracking and porosity and lots of things you can't tolerate. So there's a whole host of processes that you need to go through to make sure that the castings that you produce are free from defects above a certain size, so that you've got the integrity that you need. So those first forged and machined Blisks are really about proving the performance of the engine, the out and out. Can it make the power? Can it make the efficiency? Do all the other systems work? In parallel with that, we have to sort out the casting process, and that will include the casting, the post-treatment to get the integrity of the casting right, the in-house scanning, and then the machining and grinding ops to get the thing machined to tolerance and balanced properly. So all of that eventually will be in-house.
Excellent. Lord is asking, and I believe this is in relation to the fuel, will your sensors handle floating point error? Do you understand?
Yes, the whole system is perfectly sufficient to do what it needs to do. So all of those things will be covered as part of the development process.
Jonathan has another question.
You've got to remember, with all of these things, nothing is left to chance. Everything has to be tested in every scenario that it's ever going to be used. And so the phase that we're entering at the moment is building each of these subsystems, putting them on test rigs, and taking them through the entire operational envelope so that we know that they do what they should do and that they do it repeatably. And only then can you start to put the systems together and think about going flying.
Mm-hmm.
Jonathan is asking, will there be room left in the landing light recess to add later such things as radar antennas or gyrosensing, other special night vision cameras?
There won't be room in that particular bay. You would never believe it in a helicopter as big as HX50, but we have a real packaging problem in the nose area because there's so much stuff has to go in there, and so that area is full. Anything else that needs to be mounted in there, we'd have to look at a different way of mounting it, and there are ways that we can do it, but it would have to be outside of the envelope that's already provided for. So no, the nose is full. It's beyond full, actually. Needs a bigger nose.
Okay. Lord's asking a question that I think expands maybe on his last one. Let's see if we can make good sense of it here. Will the physics engine null the floating point error from the object recognition sensor? Should use dedicated ARM GPUs on the sensors and cameras and have it feed the real-time process data to the physics engine that the digital cockpit uses?
So I understand physics and mechanical engineering and aeronautical engineering. That sounds very much like a question for Martin. So I'm not gonna, I'm not gonna talk electronics and embarrass myself. I'm not an electronics guy. So the mechanics of the situation works fine. We know what we need from the sensors. In terms of the software and the electronic implementation, that's one for Martin. So Lord, if you just email me that question, I'll sit down with Martin and come back to you with a sufficiently technical answer.
Okay. And Carl has the next question. Does the digital cockpit display show both AGL and MSL altitudes?
Yes, it does. So you've got two ways of doing that. So you've got your barometric altitude conventionally, and then you'll have a GPS-derived height, or if you have the radar altimeter, then you have a rad alt as well, and both of those can be displayed as part of the altimeter. I'll stick that in next month's presentation, and I'll show you what we've done on the user interface to explain that.
Okay. And Sean is asking, is the flight computer still being developed in conjunction with Avidyne?
No. No,
Okay.
all of that's come in-house. So at the moment, the only external devices that we're using as part of the DigiCockpit are the peripherals. So the radio, the audio panel, the transponder, the GPS source, and probably the AHRS as well. We've just found a source of or we think we found a source of a new AHRS that's going to work for us. The rest of it is us.
Okay, we skipped the question here from Jonathan as well. There was another one related to that, which is, it looks there will be a hill simulator that could be used for flight training at the Hill factory. Is that the case? What is your plan on flight simulators?
Yes, we will be producing simulators. Other than getting to the point where I've got a flight dynamics model that's sufficiently well defined that it will be meaningful, I've done nothing with that yet, other than my objective is to make sure that we can put pilots in scenarios that we would never want to put an aircraft, in addition to basic platform awareness and procedural training. So the procedural training stuff, it's easy to push those out. The really high fidelity simulators will probably be a bit too expensive to put out to all of the distributors. And so, yeah, they'll be based at key locations around the world in the factory.
Okay. Next question is from Ian, and it's a bit of a statement and a question. So it says, incredible, you're designing the engine from scratch, but it took Pratt & Whitney 40 years or so to get the GF from drawing board to operation. Obviously, you will do this quicker, but to cover containment, ingestion, erosion, reliability, etc., is going to be a tall order. Very impressed. So do you want to comment on that?
Yeah, there's a big difference between doing stuff for the first time and essentially just harvesting all the technology, the proven technology that exists, and doing a good packaging and manufacturing exercise. So when Allison developed the C250 engine, that was an incredibly well-funded program with incredible engineers, with the backing of the US military, but they were inventing stuff for the first time. You know, that was the first engine of a class. They had to learn how to do all of these things from nothing. We've got sort of 70 years of gas turbine experience that we can draw on, and the people that now work for me are the guys that used to work for them. And so we bring all of the knowledge from the industry on know-how and experience that all of these capable people have into our business. So we're really just building an engine based on best practice. We don't have to invent best practice, and we don't have to learn those lessons the hard way. So it is a world of difference. And so the things that we were doing, either they're now the things that you're talking about are now either baked in to the certification standards and the advisory circulars, or they're things that are just accepted by the community. And it's a small community of engineers in the world that designs these things. It's either just a well-trodden path for all of those people. So we're not inventing anything. We're just doing a really good job of the value engineering and the quality and the manufacturing engineering of well understood engineering and working practices for these engines. But it is still a big job.
I just remember that probably a good comparison would be if you were to build a hydrogen engine, that would probably be obviously new and a considerable amount of time that P&W used in the past, but it is not reinventing the wheel, but is doing it on the shoulders of giants, right? That's the difference.
Yeah,
it's happening here.
Yeah, it is. And you know, we're not the first people to start making jet engines from scratch. You know, in the industrial world, there's a lot of companies that have done exactly what we've done and started making engines for bespoke applications. You know, if you look at the people that now make the engines for the business jets and things like that, those were companies that came to the game quite late and just drew in the people that had got the expertise and delivered an engine for an application. But it's based on those decades of hard-won knowledge that's gone before. So yeah, this is yes, it's a new engine. Every component is new. Everything is designed from scratch. But none of the concepts are new. None of the processes are new. You know, we're not having.
It's our engine, but not a new engine.
It's ours. Yeah, it's just it's our IP and it's our manufacturing. But the knowledge is now humanity's knowledge. You know, it's already been done.
Good. And Glenn is asking, have you covered the gearbox yet? Well, we have covered that extensively in other AMAs, but you can touch base on that because today was the fuselage mainly.
Yeah,
airframe,
so we built the first main rotor gearbox in the summer, and it was a race to get the first one together in time for an event, and we've since stripped it down. A lot of the components are sat on this table next to me at the moment. They've been away, they've been measured, we've refined some manufacturing processes. We're currently, as I said earlier, doing the copper plating to allow us to harden the gears and then remachine them. As soon as that's done, the gearbox can go on the test bench. We're doing fatigue testing on gears, or we're producing the gears to do the fatigue testing that will qualify the life of the gearbox. And just around the corner over there, we have a lubrication test stand where we're optimizing the oil flows through the gearbox to, again, protect the gears, protect the integrity, and get everything working just as we want it to. So one of the areas that's most advanced in the whole company is gearbox design, transmission design, gearbox manufacture, and we're just at the moment playing catch up with our bearings to get the price point to where we want it to be for the full gearbox systems before we stick those on long-term test, because obviously we want all of our bits in there and not some of our bits and some third-party bits that we wouldn't be able to use in production.
Good. Barry's asking a question of what type of navigational capabilities will the HX50 have other than a GPS?
A compass. So it's a VFR helicopter at the end of the day. I don't believe in Europe the VORs are being maintained or replaced. I think they're being maintained, but I think they're being phased out from what I understand. And so I think there's little point in us investing in that area. I think for VFR flying, people want to draw a pink line on their iPad and have something follow it, and that's our focus really at the moment. So it is very much GPS focused.
Okay. Before the next question, Lord has another suggestion in the area of digital, and which is a simulation for guests should be coded out of the Unity 3D and run through a web-based canvas to deploy on their website via cloud. That's a good suggestion. You can discuss internally for sure.
Okay. Let's get Paolo on the call.
Yes. But it's a good suggestion. There's some good ideas here for sure. Johan has the question, next one, which is, what safety systems will surround the fuel tank?
So in terms of the integrity of the tank, so the fundamental structure of the tank is provided by the fuselage, and the structure of that tank is the main load path of the whole helicopter. So the backbone of the helicopter connected to all of the protective frames and the main crown in the top of the helicopter, all the way through to the floor. The underslung loads go straight through that front fuel tank wall as well. It's an incredibly strong part of the aircraft. So you've got your primary structure providing the volume for the tank. Within that volume, there is then a bladder to provide leak resistance in the event of a puncture or a slight tearing of any of the joints. And then within that bladder, there is a foam that prevents fuel sloshing, because obviously it's an enormous volume. So there's a baffle foam that also then acts as a fuel leak rate reducer. So if you do penetrate the tank, penetrate the bag, it can then only leak out of the foam at a finite rate, and that applies to both the main tank and the trim tank.
Okay.
And
And Melanie's asking, how do you expect the HC-50 to compete with companies like Bell, Airbus, and others for agricultural work and firefighting?
Very well is the simple answer. I think fundamentally what we've got is the ability to put a platform out there that will be incredibly inexpensive to operate and incredibly well supported compared to some of the older or more established products that are out there. I think if you're comparing us to Airbus and the H125, then that's a bigger helicopter that can lift more. The fuselage of that is designed more akin to utility work, whereas we have the centre pillar in between the front and back seats. So I don't think our cabin is quite as flexible as the A-Star for sure, but you'll just have to trade that off against the pure economics and the performance of the machine, the speed, the lifting capability, the fuel consumption, and cost. Because I think we're in a very strong position on that front, and I think a lot of helicopter operators have many applications that they could exploit if they could get their cost base down to a level that would make them commercially viable, and that really is what HC-50 is all about. And it's also a pragmatic way for the existing helicopter industry to enter a greener phase where we can operate, do all the things that we've always done, but with zero CO2 emissions.
Okay. Steve has the question: will the cockpit allow for a 6'5", 300-pound pilot?
Yes. Everybody within the customer base has been looked at for this, so yes. The one thing I didn't talk about when I was over there is just how much headroom you've got in the front of the cockpit. I think it will take comfortably a 6'8". So I think your head would just be your headset would just be touching the roof in the front if you were 6'8". So there's lots of room there.
Well, that covers the question then from Rick Walker, which is a former student of mine. He says, having flown with Misha, I can vouch that fitting in some helicopters can be a challenge for him. He's 6'6". So how well would he fit into the Hill helicopter? So I think you just answered that one as well.
Oh, he'll look tiny in ours.
So a question from Oliver is, why do you need so close control of the BOM? Like building your own bearings, aren't you finding suitable bearings from top vendors?
There is a wide variety of wonderful manufacturers out there that can produce components for you to fantastic levels of quality. But what's tended to happen, I mean, again, I don't want to go over old ground. What happened when general aviation kind of entered a death spiral in the early 1980s? A lot of the supply chain went off and focused on business jet manufacturers, Airbus and Boeing, who can afford to pay much more and have a different set of requirements really to general aviation for how they want to interact with the supply chain. And what that's meant is that components that you would want to go and buy from a supplier are just prohibitively expensive, and the cost, and these manufacturers also want somewhere between hundreds of thousands or even millions of dollars up front just to enter a product development exercise with you, and you roll that up over all the different components that you have to develop to make a helicopter, and it just becomes totally impractical. So I never really wanted to make bearings. We often joke here that it's an insane thing to undertake, but you know, when the cost of making the bearings in the first 10 helicopters pays for all the equipment that you need to buy to do it, then it becomes pretty obvious. And it was the same with the glazing. You know, the cost, I think, of the first 25 helicopters, or the cost saving on making it ourselves, pays for the machine. And it's got that bad in the aerospace supply chain. So it's not something I want to do. It's something that we've had to do. But now that we've done it, it's opened all sorts of opportunities for us. So I think it will work very well. And I think what we've got now is not just a business that's a platform to make HX and HC50, but these are a scalable suite of technologies that can make any aircraft, fixed wing or rotary. So there's lots of things that we can do now we've got the capability.
Mm-hmm. Jason, and also that is probably has to do with the critical mass that we have achieved, right? If it was like to be delivered 50 helicopters, then you would be reconsidering that. But at the stage that we are, almost 700 helicopters and climbing, the critical parts bringing in on the vertical integration becomes even more evident, right? So there's no point of outsourcing those.
With the volumes of these machines we already have to produce, the economics are a no-brainer. If you do the maths on a piece of paper yourself, you'll see it. It's really obvious that when you've got 700 helicopters to make, before you even start, you look at things very differently to if you hadn't sold any, or if you're only expecting to sell 50 a year.
Well, I remember when we were in the 50s. Remember, Misha? That was a little bit a while ago, but it's a different time now. All right, then Marcel has a question about vibration. Helicopters are very vibration sensitive. How are you going to solve this? How do you maintain low vibration levels throughout flight operation?
That's a really good question. It starts from the top and then you work your way down. So the rotor system has to be designed very carefully. So it has to be designed adequately aerodynamically for the range of performance envelope that you're seeking, and then on top of that you've got to be extremely careful about the structural design of the rotor blades. The individual modes of vibration that those blades will naturally have to be placed very carefully at frequencies that avoid rotational and blade passage frequencies and common frequency contents in the wake of the helicopter rotor, to try and minimize the amount of vibration that's transmitted to the hub in the first place. Once you've done that, then you have the option for on-hub inertial dampers and things like that if you need them. And then as you go down through into the gearbox, you've then got the ability to passively damp the vibration that's transmitted from the rotor system through the gearbox into the fuselage. And at the moment, we have a simple passive system with some anti-vibration mounts and things. As we develop, as we go on in the future, the 4 struts that support the lifting loads into the top of the fuselage will become active struts, and will actively damp the vibration before it gets to the fuselage. That's not on the aircraft at the moment, nor will it be for a while, but that's the direction I'm almost certainly going to take to get a jet smooth ride. In the meantime, we limit the vibration that comes into the fuselage. The third blade makes a big difference to what you're used to in 2-bladed helicopters. The more the better, really. There's some clever things that you can do with lag dampers to minimize vibration that comes down to the hub as well. And then, of course, it comes down to fundamental structural dynamics in the way that you design the fuselage. So we make extensive use of finite element analysis, again, to optimize the stiffness and mass distribution within the fuselage and the structure to make sure that we place all of the modes of vibration that can be excited by the frequencies that are coming down from the rotor in areas where they're going to be excited excited to the lowest extent possible, and then we use whatever tricks we can find to maximize the damping in the structure and get that stuff washed out as best we can. At the end of the day, it is a conventional helicopter, so there will be some vibration, but you can expect it to be as good or slightly better than what you would expect from a similar three-bladed helicopter.
Okay. Paul's asking a question, can you give us an idea of the sunlight radiation protection? So comfort inside the HX50 of all glass envelope. Brazil is a very sunny place and with hot temperatures.
Yeah, so this is an area that we're actively looking at the moment as part of the glazing production process. So fundamentally, the roof windows are tinted, so the whole spectrum is cut in terms of what comes from the roof. And then on top of that, we have both UV and IR coatings that are treated to the glass that can reduce the amount of radiation that comes in through the roof by an enormous percentage. It's between 70 and 90%, depending on frequencies and depending on wavelengths and depending on which coatings and which combination we go for. On the side windows, again, there's a fairly high degree of tint on the rear passenger windows, a slightly lower degree of tint on the side windows for the pilot, and a lower still degree of tint on the front windows. And all of those windows are treated in the same way with UV and IR coatings. Then on top of that, the front window has to have a hardness coating because polycarb not scratches very easily without it. And then finally, we're looking at a mixture of anti-glare coatings. Now, at the moment, there are certain combinations of coatings that you can't apply. So whether we put the anti-reflection and the anti-glare on the screens, or whether we put it on the windows is something that we're juggling with. And that's something that fuselage over there is going to be used for as a very next step. We're going to go and do some surveys of glare, we're going to do some surveys of reflection, and we'll start playing around with the extent to which we want to apply these coatings to make the experience as pleasurable as possible, no matter how sunny it is where you live.
Good.
David is asking, I assume there is no reason you can't fly the HX50 back home to the US if you live there, instead of taking it apart and putting it back together as you discussed. Do you have anything against David taking the aircraft back from the UK to the US and flying it to Faroe Islands, Iceland, Greenland, Canada, and US?
Again, with all of these things, we've got a lot of globetrotters in our community, both you guys and then Peter Wilson, Steve Brooks, and a few other guys as well that have done these epic journeys. And within the community, what these guys always say is you have to understand that that's a very dangerous thing to do. You've really got to know what you're doing. So we're all for adventure, we're all for getting the best out of your helicopter, but with something like that, you've got to make sure that you're adequately experienced, adequately prepared, adequately qualified, and you're realistic about how difficult and how dangerous it is to do it. We wouldn't be encouraging people that weren't sufficiently experienced to do that kind of thing. Just they're going to end up having accidents and doing no end of harm to themselves, their families, and the rest of us. So for people that are suitably qualified and are happy with the inherent risks involved, that's their choice. And it sounds like fun, but you guys can speak to the reality of it better than I can. I've never flown any further than the South Coast.
Yeah, very good point. This is not a question about the helicopter. It's about the question about the pilot. It's a question about the pilot. That's the question it is, which is it should be based on. It's the experience of the pilot and the comfort level that it has. I think there was going to be a good market for pilots, experienced pilots that want to do these flights back and forth for HS50 clients. They're going to be accompanying the owner. That's probably going to be a good opportunity.
Yeah, and I mean,
exactly.
don't get me wrong. I think it would be amazing. It's something I would love to do myself. I'm not a good enough pilot to do that at the moment, and it'll be a little while before I'm allowed out my office for long enough to build some hours. But when the time's right, I'd love to do something like that. But I shall be very, very careful, and I would advise everybody else to do the same.
It's a personal decision for sure.
Yeah,
of your experience.
Exactly. Yeah. So Keith is asking a question, will the aircraft be able to run back-to-back 18-hour cycles?
Yeah.
It's a machine that's meant to fly, right?
Okay.
It's a machine that's meant to be used. All of
Yeah.
the duty cycle that we subject the aircraft to in design and will be mirrored on test is about the machine working really hard. And one of the things that I've started to do as we near the completion of detailed design of all of the systems is making sure from our customer base we've captured the worst of the duty cycles. We have an amazing customer in Florida that works some machines very, very hard, and his duty is a really interesting one for us because it's unusual and it puts particular parts of the aircraft under stress, and then agricultural flying can be very demanding as well. And so all of those sorts of things we capture and we design the machine to be able to cope with them.
Okay, Berlin has the question. Sorry, I have a draft question. How many miles roughly could you do with a 5 hours flying at normal speed? Actually, I can answer this one. Actually, do a plug-in because at 5 hours speed, you can basically do 720 nautical miles. But we just have to launch something really cool for everybody to check it out. On our website, you can play around with our range simulator. So you can put the helicopter anywhere in the world, and then you can play around with how many people and what's the fuel that you have. You see the range, the ring range of that helicopter at anywhere in the world. It's very cool, and it's in our website. Go and check it out. So it's a good thing for everybody to go and play around with it. Huh?
Really,
Okay,
really a neat
and
time
Ben,
to sort of announce that as well. Sorry, just if you go to the website, just under the HX50, there's a drop down on the right hand side. You'll see the range configurator there, the range configurator. So, like Ruben said, play around with that. I think you'll really enjoy it. We've for this exact question, that's why we created it, because we know a lot of people, they want to be able to visualize how far the aircraft can actually fly, and it's quite amazing. I played around with it. We have it in our presentation now, and when you look at North America, like in the US, when you look at Europe, and you look at South America, in one fuel tank with a 5 hour range, you're able to touch, not quite, but almost in the US, most of the states from if you're starting out from the center. And the same thing goes for Europe. If you're starting out from the center, you can pretty much go to any part of Europe on one fuel tank. So it's amazing to be able to see that.
All right, and then Ben is asking, what is the cruise speed? Well, it comes back again, Jace. What is the cruise speed? I think it's all over our website, all over our presentations, but people keep on asking. I don't know why, but they keep on asking, what is the cruise speed, Jace?
Yeah, well, the cruise speed is 140 knots, but if you have the wheels, it might go faster.
All right, answer that one.
Okay.
Yeah.
Carlos is asking, when will you have your first certified unit ready for sale?
2026, so summer 26.
Okay, that's for the HC50.
That's just to clarify. Exactly.
the-
C. Okay, HC50.
C for the commercial version. Yeah. And for the HX, planned to be end of 2024.
Yep, that's
Okay.
great.
Okay, Jonathan has another one. He's been sharing a lot of good questions here. Are the Monolodge built-in floats only one-time emergency use, or they can be repacked and used again?
No, they'll
Both,
be able to
right?
be. Yeah.
Both.
Yes.
Both.
Yes. So
Basically both. You can clarify that one. Yeah.
yeah, the floats can be repacked and used again. So
But they are for
So the
emergency,
design-
right?
they are for
Yeah, to
emergency.
be
Oh yeah.
around.
Sorry, I misunderstood the question.
Yeah.
Yes. So
Yes.
they're not utility floats. So you wouldn't want to use them every day, but in the event of an emergency, they can be repacked.
Just to explain the process, you hit a button, there's a tank of helium that inflates the floats, they pop open, and you can land on water for the emergency purposes, but it is a fairly involved process to repack them. So you're going to have an engineer to do that. The tank's going to have to be sent out and recharged, reinstalled in the aircraft, so it's not something that you're going to do just for fun. Yeah. Okay, next question is from Mark. When will you first run the engine?
The target is March next year, so we've put a window on that of March to June. We're on track for that as we stand at the moment.
Okay.
Okay.
And by the way, just an update on our current timing here. We have 13, actually right now 12 minutes to go. We have a lot of questions. This time it has been packed with really good questions. I'm afraid we're not going to be able to answer all of them. We have a really big lineup of questions because we want to make sure that we end at 2 hours since the beginning. Otherwise, these sessions will go on and on and on forever. And it's a good motivation for you to come earlier in the next one. We're going to be announcing the next AMA soon, and it's going to be coming up in about a month or so. But we're going to be cutting off again in about 12 minutes. So next question is, but with Keith, will the electric wheel steering be able to have a perimeter grid stop to prevent driving off designated private pad area in the event of steep drop-offs for personal hangar locations?
It's technically possible. There are no plans for that to be included at the moment. Again, we've got to limit the scope of what we design. Otherwise, we'd never finish. So at the moment, it's a system that is completely under the control of the pilot at all times. So you can control it via your iPhone, or you can control it via the puck in the cockpit, and it's for you to drive it where you want it to go.
Yeah. Ryan's asking, at this point in time, is the production timeline still on track as per the last update? First flights and customer orders, etc.
Yes.
Excellent.
Okay, Ben, can I visit the site and meet Jason? Yes, we do have the next date is January 27th. But Jason, this is a question for you. Can people go and meet you? It's going to be on, again, next one available is 27th of January, but comment on that. What is the experience when they go and visit?
Yeah, we've again, when you're doing something like this, when you're coming in from a standing start, it's really important that we're seen to be open and transparent, and we've done that all the way through. In the old days, people we used to just accept people as and when they wanted to come because there were fewer of them. Now there are literally tens of thousands of people in the sales pipeline, so we have to be a bit more organized. So we do scheduled tours every second Friday of the month, and the next available one is the 27th of January, and we're happy to welcome groups of people. You get to see, you come and see the facilities, you can come and see the hardware, you can come and interact with the staff, and then I come along and you get to meet me and ask any questions you want. And I've always been very open and transparent, and unless it's something that I absolutely can't answer, then I'll always answer anybody's questions, and nobody's managed to offend me yet, so I'm pretty open-minded about what I get asked.
Excellent. Keith is asking, the door handles, do they have a sensor to let the pilot know if they've been unlatched?
No, they don't. This is a purposeful policy decision on our part. So fundamentally, if it's not been latched, the handle will stick up in the air or stick out on the outside one. So it's visually obvious. It's a natural flag that it's not closed properly. If we start putting door close sensors on, like you have on your car, and all the other sensors that all of my engineers would dearly love to have, you're going to have an aircraft that within a year starts throwing lovely orange lights on the digi-cockpit, just like your car does, and needs to come back to us and be fixed for poor connections and bad sensors and this, that, all the things that we're all used to in modern cars. And for an aircraft on a 5-year warranty, that would be really bad news for us, and really irritating for you guys. So we will only put sensors on the aircraft where they are absolutely, totally and utterly necessary, and then we spend a bunch of money making sure we buy the best ones and that the installation is very, very carefully thought out and implemented, because sensors and micro switches and things like that are horrible from a reliability point of view. So we want the fewest number of them on that we can possibly get away with. So yeah, it's a different strategy to what you do in a car that you're expecting to keep for 2 or 3 years and then move on to somebody else. These machines are going to get to be 50 years old and still in service. So you want the least fiddly stuff that you can possibly get away with.
Steve is asking, Jason, you mentioned that wheels would have a problem landing in deep snow or swampy areas. Is this mitigated by the bare boots, and is this still the plan? There's an
Yes.
engineering, is it his engineering sub-project? Yes.
Yeah. I think the bare paws basically keep the wheels out of the soft ground. If you think about wheels down, undercarriage doors down and open, if you were to then go and land yourself in really soft ground, you're going to fill your undercarriage bay with snow and with muck and all sorts of stuff that you wouldn't want in there. Then your undercarriage won't retract. So you've got to keep the undercarriage out of that sort of stuff. So the bare paws are designed to reduce the bearing pressure, spread the load, keep you on the surface. But if you're in conditions where it is so soft that that's still not good enough, then it's really not a good idea, and you either need to question whether you should be landing there at all, and if you are sure that you should be landing there, then you're better off with the skids in that case.
Okay. I can bundle these next two questions together. They're from Ryan and Martin. So are there any updates on the website to the extras that are going to be offered? And is the pricing set for those?
No, there's no updates yet because we're still working on primary systems. It will be the very last thing to go. I mean, one of the things that is a hot topic at the moment is how we bundle the features in the 2-axis and the 4-axis autopilot. And so there's likely to be some tweaks there. I don't have any intention of changing the price point of the options. I think they were competitively set in the first instance, and that remains the case. But we've got to finish designing those things first before we set the price is hard and fast. So I apologize, but that will be right at the last minute because we're just not looking at it yet, other than the primary interfaces for those systems with the main aircraft.
Next one is from Rulof, and he says, "Hi Jason, this is Rulof. Great update and fantastic to see the full-size ship for the first time. My question is at what point is the fuselage is the color applied, and how long will it take to cure? Because there's only 10 days to build, right?"
Yeah. So essentially, the way we will produce those in production, and this isn't final yet, but one of the techniques we're looking at is applying the primer to the mold before we start laying up the fabric, so that the primer keys to the fabric and also to the resin properly. That will give us then a high build primer layer that allows us to sand the body down and prep the body for painting as soon as it comes out of the mold, just the limited prep that's required. And then you only need your color coat and your top coat on top of that, and that will be done as it is in automotive. So paint finishes go on very quickly in production environments. And I should say that my brother that will be painting the first one runs a paint shop, and so we've got color matching, and we've got all of the processes in place to do this at the right kind of volumes that we need for production. So don't worry about that. That will be basically the ship will be built on a 24-hour period, and then the following overnight the paint will be applied and cured, so it'll be ready the next day. So the whole fuselage, from fabric coming in to a painted fuselage with glazing on, shouldn't be any more than 2 days.
Okay, wonderful. David saying there is a forum online where pilots are saying that there's been a 1-year delay, bringing us to the end of 2024. Do you want to comment on that?
My job here is to provide the best light helicopter that the world has ever seen, and that's what we're doing. And there's certain things in a project as complex as this that are just unpredictable, and we can only deal with what's in front of us. Nobody is getting a helicopter until I'm satisfied that it's safe, until I'm prepared to put my own family in it, and I'm prepared to let all of these people that have supported us over the last few years to develop this aircraft, I need to ensure their safety and make sure that the product's right. You know, nobody wants a bad helicopter, and I certainly don't want to be supporting 700 helicopter warranties that have got lots of faults because it was pushed out of development too soon. So we're working as hard as we can. I'm working the staff as hard as I can without destroying morale and starting to lose people, and you know, I think when you set out on these projects, there's only a certain extent that you can predict the timeline to, and that's just the nature of engineering. And we will always be transparent, and we will always tell you what's in front of us with the best information as it becomes stable and mature enough to communicate. You know, I'm not going to change the timescale every 20 minutes when something goes wrong or something goes right. You know, we just give you the trends as they become clear.
Excellent answer. Excellent. Well, next question is funny, and it's an opportunity for us for another plugin, which is, are you guys shopping at the same clothes shop? Yes, we are. It's Hill. It's Hill. It's Hill Shop. And by the way, the merchandise website is going to be launched in a couple of weeks, max couple of weeks before Christmas. And all of you that have ordered items during our last event, they're going to be starting to be shipped out in a week or so, week and a half or so. We're going to be items. So go ahead. You can also dress as we are, and they have other really beautiful items in your closet. And that's going to be Hill Classics that Misha and I were wearing. And Jason is not wearing them. I don't know why, but I think he said it was too warm. But he only has jackets, I believe, right? You don't have these polos.
Yeah. And my I've got a workwear fleece, the same as the rest of the guys, but mine's covered in carbon fiber and resin at the moment, so it's in the wash.
Excellent. Backman is asking two quick and easy questions here. From which side will the HX50 be flown, and which way do the blades spin?
The pilot will sit on the right, and it's American and British rotation, so conventional for most of us. So it'll be counterclockwise when we do from above.
Excellent.
Okay. And right now we have time for just two more questions. I'm going to read one question, then Misha reads another question. We're going to be wrapping up. Just nail it down right now. It's 7 o'clock in UK time, 2 hours after we start. And by the way, before we read these questions, Jason, we have to update our sales because unfortunately we no longer have the 500, actually the 476,000 pound price is no longer available. Those are taken. So right now is 477,477. And that price will be available for the next 3 serial numbers. And next question is, the recesses of the engine on the top of the hull looks to be great place for water entrapment. Is this addressed?
Yes. Yeah, there's drain channels in there. There's a drain channel between the tail boom and the tail boom interface, so the back of the monolage and the tail boom.
Excellent. And Freddie's asking the last question here. Talk about the windshield defrost wipers, heated glazing, etc.
Again, that's a hot topic at the moment. We had a look at electrically driven local fans to try and avoid piping, and we've gone back to a more conventional system at the moment. So as you're aware, it's a climate control system, so you've got air conditioning and heating in there. The defrost vents will all live in the what we call the wolf's head, so the top of the panel to defrost the windshield. You've got air conditioning in the roof and also air conditioning in the instrument panel in front of you as well.
Excellent.
Very good. This was absolutely a phenomenal session. All of the previous ones were very exciting, but I will say this one was very, very special. It was great to have you all. We had connections from all over the world, all continents. We surpassed more than 2,000 connections. Again, once more, 2,000 people watched live this event. It was wonderful to have you all. We're going to invite you to be on the next one, which is going to be coming up and announced soon in a month's time. So right now, I'll say goodbye to each one of you, and you as well.
Yes, thank you everybody for attending today. It was really good to have all you guys' questions as well, and thanks a lot to Jason again for his openness and willingness to be able to answer those questions for everybody live here. So really appreciate that.
And thank you from me to everyone for joining the session and following this journey as we bring HX50 to market. Thank you, guys.